Number 7. You might look at this question before you read it and think to yourself that you're going to need to get out your calculator because we're going to be doing calculations. You'd be wrong. In fact, this is actually more conceptual in nature. So let's talk about it. We're talking about molar volume and gas density. Number 7. Suppose that a 5.00 liter sample of O2 at a given temperature and pressure contains 1.08 times 10 to the 23rd molecules. How many molecules would be contained in each of the following at that same temperature and pressure? So let's go through what we are holding constant. We are holding temperature and pressure constant. And so that means that Gay-Lussac's law of combining volumes and Avogadro's law also apply. Okay? Now we're not going to be dealing with moles, so we're not necessarily going to be using Avogadro's law. We're dealing with molecules, so we're going to stick with the law of combining volumes. So how many molecules would be contained in each of the following at the same temperature and pressure? So this is 5 liters of a gas. It's O2, but that actually doesn't matter. A is 5 liters of H2. It doesn't matter the species of the gas. Equal volumes of different gases at the same temperature and pressure contain equal number of molecules. So I do not have to do a calculation here. It is 1.08 times 10 to the 23rd molecules. Because equal volumes at the same temperature and pressure. Well, B is the exact same thing. 5 liters. It's a different gas, that's true. But that doesn't factor into this idea. The gases can be wildly different. The molar masses of the actual gases themselves can be hugely different, significantly different, radically different. But that doesn't matter. It just matters, do we have the same temperature and pressure, and are the volumes equal? And here, all 3 of those conditions have been met. So it's the same number of molecules. Now when we get to C, we see that we don't have the same volume. We actually have double the volume. Oh, if we have double the volume, let's double the number of molecules, right? It is that simple. So we'll go the number of molecules times 2. I can do this in my head because I'm crazy smart like that. If the volume is twice that of A and B, as long as we're still at the same temperature and pressure, then the number of molecules is simply twice the given number of molecules. And yes, it is that simple.